AI in orbit, the economic and legal prospects of space data centers. Alright, let's get right into it. We all see the AI boom happening down here on Earth, right? But the next real frontier for data, and you guess it, the next big battleground for tech billionaires is literally out of this world. We are talking about a brand new space race, but this time it's all about data and AI in orbit. So you might be asking, why on earth are we looking to space? Well, it all kicks off with a huge problem right here at home, energy. I mean, a massive problem. By 2028, it's projected that data centers, the backbone of AI, could eat up a staggering 12% of all electricity in the United States. That incredible hunger for power is putting a serious strain on our grids. And the solution that's on the table is about as ambitious as you can get. You've got tech's biggest rivals, guys like Jeff Bezos and Elon Musk, both pointing towards the same wild idea. Just launch our AI data centers directly into space. The thinking is you could harness the non-stop, unlimited solar power of orbit to fuel this whole revolution. But it's not quite as simple as just packing our most power-hungry machines onto a rocket. This dream of orbital data centers runs headfirst into the cold, hard, unforgiving laws of physics. Yeah, space gives you infinite energy, but it also hits you with two giant challenges: cooling and radiation. See, here on Earth, cooling is easy. We've got air, we've got water. We use them to pull heat away from the hot computer chips. It's a process called convection, and it works great. But in the vacuum of space, there's no air, no water, nothing to transfer that heat to. The only way to cool things down is to radiate the heat away as light, which is a much slower process. Think of leaving a hot pan on the counter to cool on its own, but way less efficient. And this isn't just a technical challenge, it's a fundamental rule of the universe governed by something called the Stephan-Boltzmann law. And what it tells us is simple. To get rid of a lot of heat, you need a massive surface area. There's no clever software patch for this, it's just physics. So how massive are we talking? Well, we'll get this. For just one pretty small 2 megawatt data center, you will need a radiator panel stretching almost 4,000 square meters. That's nearly the size of a football field, an enormous heavy piece of hardware you have to build and launch just to stop the whole thing from melting. Okay, so even if you solve the heat problem, you've got another huge hurdle: radiation. Here on Earth, our atmosphere and magnetic field act like a giant shield, but in space there's nowhere to hide. Your electronics are just getting slammed by a constant barrage of high-energy cosmic rays and particles. And this isn't some abstract threat, it has very real consequences. Standard off-the-shelf electronics, their lifespan gets cut down to just a couple of years in orbit. HPE put a computer on the International Space Station as a test, and guess what? Nearly half of its hard drives failed. If you had a server constellation the size of Starlink, you could be looking at hundreds of radiation-induced errors every single day. Okay, so with all these massive, expensive physics-based problems, you have to be wondering, why is anyone even trying this? It seems impossible. Well, here's the twist. The real business case for these things isn't what most of us assume. It's not about replacing Google Cloud or AWS for us down on Earth. And this is the key insight, the whole reason this makes sense. Orbital data centers are designed to solve a satellite data problem. It's about processing the absolutely colossal mountains of data that are generated by other satellites in space right at the source. Think about how it works now. A satellite takes a bunch of high-res images, right? It has to wait until it's flying over a ground station. Then it has to beam those huge files down to Earth. Then we process them on the ground. And only then do we get the useful information. With an orbital data center, you cut out all those steps. The satellite sends its data over to the data center right next door. It gets processed instantly, and you only send the final valuable insight down to Earth. It's a game changer for speed. But even with this really smart niche application, the cost has always been the killer. I mean, launching tons and tons of servers and giant radiators. It was pure science fiction until now. The entire future of this industry really hinges on one single thing, making it dramatically cheaper to get to space in the first place. And the change we are talking about here is just staggering. Right now, with the Falcon 9 rocket, you are paying almost $3,000 for every single kilogram you want to send to orbit. But SpaceX's Starship, the target price is around $100. That's not just a little bit cheaper, it's a fundamental economic revolution that suddenly makes the idea of launching data centers actually seem plausible. And don't think this is some far-off dream. The ball is already rolling. We are talking about the first demo missions from companies like StarCloud and Axiom Space as early as 2025. By 2027, just a couple years later, we could see the first commercial units go online, probably for defense and Earth observation. Then by 2031, you get a real growth phase with much bigger facilities. Fast forward to 2035, analysts think this could be a market worth nearly $40 billion. So just as the tech and the economics are starting to line up, a whole new can of worms is opening up. As we get ready to launch our data into orbit, we are crashing right into a huge legal and regulatory vacuum. This is the final frontier of rules. Okay, so the main rulebook we have is the Outer Space Treaty from way back in 1967. It basically says that any object in space, like a data center, is under the laws of the country that registered it. So a US registered server has to follow US law. Sounds simple enough, right? Well, in theory, yes, but the modern world makes it way more complicated. For example, what happens when you have an American company, a European space agency, and maybe a Japanese corporation all chipping in to build one big orbital platform? Whose laws apply then? The treaty is pretty quiet on that one. And what about liability? The law was written assuming a human was always in control. But what happens when a fully autonomous AI running one of these data centers makes a critical error that causes a data breach or damages another satellite? Who's to blame? The programmer, the owner, or the country that launched it? And this leads the most fascinating and maybe troubling question of all. Could a company just decide to register its data center in a country with really weak data privacy laws? Could they create a kind of data haven floating above the Earth, totally outside the reach of US or European regulations? Welcome to the new Wild West. So as we are standing right on the edge of this new era, that's the real question we have to ask ourselves. Is putting our digital infrastructure in orbit the brilliant next step for humanity, a way to solve our energy problems and unlock incredible new technologies? Or are we just taking all our old problems, our competition, our legal gray areas, our endless demand for more power and just launching them into the sky?